Hi students, my name is Nagarjuna. I take your physics classes. So there is a chapter called Motion in One Dimension in your first PUC. This is the chapter is related to your 9th standard chapter called Motion. In class 9. So this is the chapter in your first PUC. The concepts will be exactly same how you had learned in your 9th standard. Like distance, displacement, speed, velocity, average speed, average velocity, uniform motion, uniform acceleration, non-uniform motion, non-uniform acceleration, equations of motion, graphical representation of motion, right? And the numerical, exactly similar, right? And you can say here, almost these chapters will 100% present. In an advanced way, we will be learning this chapter called Motion in One Dimension. Before moving into the motion in one dimension, in these classes, what we are going to do is, let us brush up your knowledge from your basics of 9th and 10th standard, how those concepts will be useful for you in your first PUC and second PUC we will be learning it now, right? Now, in today's class, the concepts we will be covering is about distance, displacement, speed, velocity. To look, these are the 4 important physical quantities, may be simple, but there are many things to understand behind these 4 important physical quantities, right? And let us start the concept called distance. So here I am writing distance here. And displacement. Here itself let me write displacement. Right? This is the distance is the total path covered by a body. Here we have not at all discussed about the direction of the path traveled by the body. The displacement is a physical quantity which is the shortest path between initial and final points of the body. Let us discuss more about distance and displacement. So this is the distance is a scalar quantity. Scalar quantity is the quantity which is having only magnitude but not direction. The magnitude means what? It's a value. So and the displacement is a vector quantity which is a quantity having both magnitude and direction. So that is what distance and displacement here. And so the SI unit of distance is meter and SI unit of displacement is also meter. Okay. Now, with a simple example, we will be understanding what exactly is the distance and displacement. With a simple example, look at this. A body is starting from point A and it is reached to the point B, and from here to here the path length is 100 meters. And from here the body is traveled to the point C. The path length between B and C is 15 meters. Okay. Now the concept you can see, I am going to find the distance and displacement different cases here. And what is the case I am considering first? So from A to B is the case I am considering here. What is the distance and displacement from A to B? That is the concept. A to B. What is the distance? It is the total path covered by the body. From here to here, there is a total path covered by the body is 100 meters. Okay. Now, what is the displacement? Displacement is the shortest path between initial and final points. Where is the shortest path? So this is the point A, initial point, and this is the point B, final point. So what is the displacement? The shortest path between 2 points is a straight line path. Remember, not only here, if I draw two different points here, the shortest path between these 2 points is this. Is this the shortest path? No, right? So is this the shortest path between these 2 points? No. The shortest path between any 2 points, if you want to draw, that will be definitely a straight line path. In the same way, the shortest path between A and B is the straight line path, which is also 100 meters. So the distance is equal to displacement in this case. Let us see the distance and displacement values in the next case. So what is the next case I am considering here? The body is starting from A and reaching to B. From B, it is reaching to the C point. Okay. Now, what is the distance and displacement here? That's a question. What is the distance and displacement here? The distance A to B and B to C. Distance is what? The total path covered by the body. The total path covered from here to here 100 and from here to here 50, and total it is 150 meter, and displacement is what? Displacement is the shortest path between initial point and final point. Where is the initial point here? This is the initial point. And where is the final point here? So this is point C is the final. The shortest path means draw a straight line. Already there is a straight line. What is the path length of the straight line? 100 plus 50, it is 150 again here. Right? One important statement I am going to discuss with you here. Listen carefully. As long as the body is moving in a straight line without turning back, body is moving in a straight line, A to B, then B to C. Distance and displacement values will be same, you can see here. From A to B, the body is moving in a straight line without turning back, distance and displacements are same. From A to C, the body is moving in a straight line without turning back, distance and displacements are same. Once the body is started turning back and distance value will be more, displacement will be less. How it is possible? We will be discussing in the third case. So what is our third case? You can see the body is starting from A to B, B to C, and C to A back. Understand? C to A back. Right. Let's start the distance and displacement here. So distance and displacement here. What is the distance? Total path travel. How it is traveling? A to B 100, B to C 50, total 150. C to B 150, right? 150 plus 50, 200, and B to A again, 200 plus 100, it's 300. Understand? So you can check A to B how much, B to C how much, C to A how much, count everything, add everything, right? So this is 300 meters. So what is the displacement here? So displacement between what points? Whenever I say the word called displacement, the first thing you should recollect in your mind that what is the initial point and what is the final point. You draw a straight line between them, find the length of the straight line, that gives you a displacement. And let's see here, displacement. What is the initial point? Yes, A is the initial point. What's the final point? A is the final point. The initial point is this one. The body is traveled like this and came back to the same point, right? Can you draw a straight line between the two same points? Impossible. So there won't be any path length between the two same points. So that's called the displacement will be 0. In this case, distance is not at all equal to displacement and distance is greater than displacement, right? But in first two cases, distance and displacements are same. It is just because in first two cases, the body is only moving forward without turning back and it is moving in a straight line. Once the body started turning back, distance will be more, displacement will be less. Okay, clear? And let us add one more case for this same example. One more case for the same example. And what is that case? And look at here, the body is starting from point A to B to C to A, and from A it is reached to the point X. How it is moving? A to B, B to C, C to B, and B to A, and from A it is reached to the point X. So from here to here, the path length is given as 25 meters. Okay. So what is the distance and displacement in this case? Distance and displacement in this case. So you need to count everything. From A to A it is 300 meters already there, and from A to X it is 25, and total it will be 325 meters. It's a distance. Because distance is the total path traveled by a body. That's it. You just need to add all the individual paths traveled by the body. That's it. But displacement will not do it. Displacement is the shortest path between initial and final point. So where is the initial point here? A. This is initial point. And where is your final point? X. This is your final point, right? So what is the straight line length between those 2 points? A is here, X is here. What is the straight line length? It is 25 meters. Is it correct answer? No. The answer is minus 25 meter. It is just because from A, the initial direction of the body is right side. The body has come back to the point A and started moving left side. You can see. So this is the displacement we are finding left side of the starting point. Then your displacement will be negative, right? The displacement will be negative. So negative 25 meters. That's a concept, the basic idea about distance and displacement. Right? Now, let's see some more small example. Small example. The body is moving in a circular path. The body is moving in a circular path. Let's divide the circle into 4 parts. So 4 equal parts have just divided the circle, and this is the origin. And you know the radius of the circle is r given, and this is the point A, and this is the point B, and it's C here, and it is D here, right? Here also, let us discuss about different cases available. So the body is starting from A to B, and let's find distance and displacement. The body is starting from A to B. What is the distance? A to B. This is A and this is B, right? Only they have given the value called R is the radius of the circle. That's it. So this is the path length from here to here. What is the path length in the case of circle? Right? If the complete circle path length is the circumference, which is 2 pi r. For the complete circle, what I can write? Circumference. For the complete circle, circumference is 2 pi r. Here, only the path length we need 1/4 of it. Yes or no? It's 1/4 part of the circle. This is another 1/4. This is another 1/4, and this is another 1/4 of the circle. Now, this 1/4 of the circle is pi r by 2. Okay. And this is pi r by 2, this is pi r by 2, this is pi r by 2, right? So now the distance is pi r by 2. And what is the displacement? Right? Again I am telling you, again. Displacement, if I tell you, the first thing should be recollected by yourself is what is the initial point and what is the final point, right? So initial point is A and the final point is B here. Initial point is A, final point is B here. Let us draw a straight line between initial point and final point, and this is the initial point and this is the final point here. And one more point I just wanted to tell you here. The direction of the displacement. We had already discussed that displacement is a vector quantity which will have a direction in it. So the direction of displacement is always from initial point to the final point. So it's the initial point and this is the final point. See the direction of the displacement. Okay, clear? So let's come back to this question. So what is this question? The displacement. So what is the straight line path length? That's the question. So its radius is r, and from here to here is also the radius r. And if it is a triangle, you know the base of the triangle and height of the triangle. You can find the hypotenuse of the triangle. SR, no. The hypotenuse of the triangle is the displacement, which is equal to square of the base plus square of the height. So from here what I can write, square root r square plus r square is 2r square. So that I can write it as root 2 into r. That's a displacement of the particle. Okay, clear? And let us discuss one more. So what is this? From A to B, B to C, and C to D. So this is what the path traveled by the body. What we are going to discuss is distance and displacement. And let's how the body is moving? A to B, B to C, C to D. What is the path length traveled? I told you this path length is pi r by 2, and this is pi r by 2, and this is pi r by 2, right? All together, the total path traveled by the body is 3 pi r by 2. That's called distance. Is it distance or displacement? It's a distance. So 3 pi r by 2 is the distance. Then what's the displacement? And where is the displacement here? So displacement I told you so many times. Where is the initial point? Where is the final point? Identify, draw a straight line. So this is the initial point A. Final point is B. Identify these 2 points, right? Then draw a straight line. And how to find this length of the straight line? So this is r, base of the triangle, and this is also r, height of the triangle. And you know this is the hypotenuse of this triangle, right? You know how to find the hypotenuse by using Pythagoras theorem. So this is root 2 into r. Okay, clear? In this way you can find the displacement concept also. So, one more example, if you want to learn, look at this, a triangle here, it's point A, B, C. This is 3 meter, it is 4 meter. Okay. Now, the body is traveling from A to B and B to C. The question is, find the distance and displacement. Body is starting from A, reaching to C. How? Via B. A to B, B to C. Distance. A to B 3 meter, B to C 4 meter. 3 plus 4 will be 7 meters. And what is the displacement? I told you already, displacement, initial point and final point identified. Yes, identified. Draw a straight line. Yes, already the straight line. And you can easily find out the straight line by using the Pythagoras theorem. The straight line length you can find. What is that? Square root, base square, 16 plus height square, 9. Root 16 plus 9 is root 25, which is 5 meter. And what you should understand here? Distance is greater than displacement. Distance is greater than displacement. Distance may be equal to displacement. You can see here. Distance may be equal to displacement or distance greater than displacement. Right? So displacement cannot be 0 if the body is moving. Sorry. Distance cannot be 0 if the body is moving. because it is just adding up. As the path is traveling, we need to add to find the distance all the paths travel. But the displacement is not like that, right? It can be zero because when the body is starting from one point and it has come back to the same point, the displacement will be zero, right? So this is the basic introduction about distance and displacement, and let us learn about the speed and velocity and different cases in the speed and velocity we will learn now. I hope you understand the concept of distance and displacement in the session. Let us solve few conceptual based questions on the same distance and displacement. Then we can move on for speed and velocity talk. Let's start. A body is moving along a circular path of radius r. There is a circle. Radius of the circular path is r. Find the distance and displacement when it completes 2.5 revolutions. So let's find the distance and displacement when the particle finishes 2.5 revolutions, right? This is what I am considering the origin, the starting point. One revolution. How much is the distance traveled? One revolution. One revolution, the distance traveled will be 2 pi r. I hope you remember, that's a circumference, right? Plus the second revolution. The distance traveled 2 pi r plus the third revolution. What is the third revolution here? The third revolution will be, that means only half, right? 2.5 revolution. Third part is only half revolution. So from here to here, the distance will be pi r. So what is your answer? 2 pi r plus 2 pi r, 4 pi r plus 5 r. It's 5 pi r is the distance, right? Displacement. Again I am telling you, initial point, final point, identify first and draw a straight line. Initial point A, final point after 2.5 revolutions. Where will be the final point? 1, 2, 3. See here, half. A and B here. Final point, initial point. Draw a straight line. So what is the length of the straight line? Is it the diameter of the circle? Yes, the diameter is 2r. Yes, this is the distance and displacement. Sometimes the questions will be asked, the ratio of displacement to the distance, r, the ratio of distance to the displacement. And let's write, for example, if the question is to find the ratio of distance to the displacement, distance is how much? 5 pi r. By displacement is how much? 2r. R gets cancelled. 5 pi by 2. So I can write it as 2.5 into pi. So like this, numericals can be asked. Right. Let's see the second question. Numerical value of ratio of displacement to the distance. Numerical value, for example, distance by displacement, we have found somewhere here. Distance by displacement is 2.5 into pi value is 22 by 7. So there will be some numerical value you get when you take the ratio of these two. So that numerical value of the ratio of displacement to the distance. Right? First, distance by displacement we can find out. Then displacement by distance will be very easy. So what was the situation during the theory we have discussed? Distance is always equal to, always greater than the displacement. Yes or no? Distance is always greater than the displacement. When the body is moving in a straight line and coming back, distance will be increasing, displacement will be decreasing, right? So that's why this is, distance is greater than displacement. And there is one more possibility. So many times I have told you during the discussion. As long as the body is moving in a straight line without turning back, distance is equal to displacement. So that is also a case. Distance is equal to displacement. So both together, if I write, distance will be greater than or equal to displacement. So the same thing, if I write in ratio, distance divided by this displacement comes here. When the displacement comes to the denominator here, so here 1 will be left. So greater than or equal to. Distance by displacement is greater than or equal to 1. This is greater than or equal to 1. But our required answer is displacement by distance. So a displacement by distance will be, distance by displacement is greater than or equal to 1, right? So then displacement by distance will be less than or equal to 1. So this is your required answer. So maybe the first time you are going to learn the objective pattern. So this is the question given as objective. In this way you should see the possibilities and finally get your answer. So displacement by distance is less than or equal to 1. Where is the less than or equal to 1? Yes, your first option is correct. The main point you must keep in your mind while solving the objective questions is that why the other options are wrong, you should know first. That's called the conceptual learning. Most of the students will be trying to find the correct answer by leaving rest of the things. So your conceptual strength will be developed when you understand the difference between the right answer and the wrong answer, and even the reason behind the right answer and the wrong answer. So practice in that way, your objective analysis and the result will improve a lot. Now, let's see the third conceptual question. It's a very, very interesting and funny question. A drunkard is walking along a straight road. So imagine this is a straight road. Here is a drunkard. How he is walking? He takes 5 steps forward. So he took 5 steps forward here. How many? 5 steps. He reached here. And 3 steps backward. I hope you might have seen the drunkards. They move front and back, side, this side and this side. So the same thing is happening here. 5 steps forward, sorry, 3 steps backward. So here, 3 steps backward. So total number of steps he made, 5 plus 3, 8, right? But is actually 2 steps ahead from its initial position, S or no. Because 5 front, 3 back, actually he moved 2 steps only forward. What we can understand here? His distance traveled is 8 steps and displacement is how much? 2 steps. Distance traveled is how much? 8 steps, 5 plus 3. The total path traveled and the displacement is only 2 steps, right? Followed by 5 steps forward and 3 steps backward. And so on, same way. Now this is the position right from here. Again 5 steps forward, 3 steps backward. 5 steps forward, 3 steps backward. In that way, he is moving. Now, each step is equal to 1 meter long and takes 1 second. Okay, for example, first case let us concentrate. What is our first case? 8 steps. How much meters he traveled distance? 8 meters. In how many seconds? 8 seconds. Okay. 8 steps. It took 8 meters forward and 8 seconds is the time period. So how much is from the starting point? How much is moved forward? Only 2 meters. Okay. Clear? Now I'm drawing one more important diagram. It is the initial position. Okay. Now, how much time he took to move 2 meters. How much time? 8 seconds. So from here to here, 2 meters forward, it took 8 seconds. Next 2 meters, it will take 8 seconds. Next 2 meters, it will take 8 seconds. Okay, clear? Now, let's read further part of the question. So there is a pit on the road 11 meters away from the starting point. So there is a pit. So 11 meters away from the starting point. So there is a pit here. This is called a pit. Now, he just moved 5 steps forward, 3 steps backward, 2 meters. And from here, another 2 meters. That means another 5 steps forward, 3 steps backward. So 2 meters. How much time for this? Another 2 meters. Again, 8 seconds only the time to. Right? Clear? Now, another 2 meter. Another 2 meter from here to here. How much? 8 seconds. Okay. So from here to here, how much is the time? Into 24 seconds. He only reached 6 meters from the origin. From the origin or the starting point. Now, from here, what he do? 5 steps forward, 3 steps backward. And let's count the number of steps. 1, 2, 3, 4, and 5th step, where is it? He will be in the pit. Because 6 here and 5 more steps, the pit will come. See the 11 meters, there is a pit here. So 11 meters, there is a pit here. 5 steps. 1, 2, 3, 4, 5. Because at the 5th step, there is a pit is given. So that means he will not come back to take the 3 steps back. So 24 seconds here, and how much time before falling into the pit? How many steps? Those many seconds. So 1, 2, 3, 4, 5. So total how many seconds here? So here 5 seconds. Altogether 24 plus 5, which is 29 seconds is the time taken by the drunkard to fall in the pit. I hope you enjoyed the numericals. This is how the conceptual questions can be answered. And this is the question can also be there in your mental ability topics. Now, this is about distance and displacement. Next session, we will be doing on the speed and velocity. Be prepared and be ready. Thank you so much.